Right, well, it's 8:33, so why don't we get started? And there may be people just rolling in, and I'll be just checking in as they come through. So thanks for joining today. This webinar should probably go on about half an hour, 3/4 of an hour, so I'll try to rattle through it. It's built off of actually a blog post that I wrote, and I've written many blog posts in the past, over the last 12, 15 years. This was probably the most popular blog post I've ever written. So there's some interest around the topic that we're going to be talking about today. And I've called this Geospatial 2.0, the quiet revolution. And I'll explain why as we go through why I've called it that. For those that don't know, I'm Matt Shee and I work for Wire there. Just a quick administrative thing. I'm always conscious of the fact I'm not in a LAN in an office, so I'm at home, obviously, like most of us are. If the internet drops, please stay on. I'll try and hotspot my phone. If not, I'm actually recording this, so if everything goes south, I will send out the recording. I'll send out recording anyway, so just be ready for that. So let's get started. If everyone joins, we've got quite a diverse group of come into this webinar. There's been a lot of interest from folks who are collecting data, investment community people, obviously the geospatial community, some folks in IoT, some people in the public sector as well that are sort of running policies for geospatial. So it's been quite an interesting mix of folks that have expressed interest, as students as well. So we'll move through. So let me just give you a quick overview of what we'll be talking about here. So I'm going to give a quick bit of history on geospatial. Some of you will know geospatial, some of you won't. I'll try and give you some sense of where it's come from and demystify a few little things there. I'm going to talk about really what I see as two parallel universes. That's really the thrust of the presentation. So I'll talk a little bit about Geospatial 1.0, and then I'll spend the bulk of the time talking about Geospatial 2.0. I'll try and paint a picture part of the way through with a customer data story, which I hope pulls all the pieces together. And then at the end, we'll talk a little bit about how this affects you, Geospatial 2.0, and a little bit about the group that I'm working with, Wire there. So, to some history. Oh, actually, before I get into the history, I thought it good to throw this slide up. Geospatial isn't very well understood, so it's actually a combination of two words. It's the Greek prefix geo, which means the earth, and then spatial is actually defined as relating to space or occupying space. So when one pulls that together, one's really talking about place or places on earth. It's the study of those places on earth. Now, I'm a geographer. I spent so I'll give you a bit of history of geospatial, of digital geospatial, and a little bit of my history as well thrown in there. So I'm a geographer. I did an undergraduate degree in England in geography, and I really studied places. My physical geography degree was focused on why is there a U-shaped valley cut by a glacier over there, and why is there a thunderstorm that's happening over there. So it's very much focused on what's happening in a particular place and the processes that were forming that. I didn't actually do any digital geography whilst I was at university in England, but I put this slide down here. In 1982, the first real desktop GIS applications came out. So that was really taking data that was digital and putting it in a computer system. Now, the history of GIS, so GIS stands for Geographic Information Systems. It actually came out of Canada. An English researcher, professor in Canada, Roger Tomlinson, came up with the idea, if I remember my history, back in the late 60s. And Esri, one of the first private companies to release GIS technology. And they actually came out in 1969. But desktop GIS goes back to about 1982. That was when we got the first ability to actually do work on computers, which brought in location-based data and allowed you to map it. So in crude terms, that's what we were working with back in 1982. 1996 was a year that was notable, and a lot of people would wonder where I got that number from. 1996. I came to America in 1991. In 1992, I saw the internet for the first time, and the University of Utah was actually on the network then to sort of test out this new idea of the World Wide Web. So I saw that, and I also saw GIS on a desktop around about the same time. Didn't really know what the internet was, and didn't really know what GIS was, if I was being honest with you. But in 1996 was when we got the first release of web GIS, as they now call it. So the ability to actually create web applications, which were GIS based. Translating that, really they were map applications. So I've got the ability, instead of looking at a physical paper map, I've got the ability to click, click, click on a computer screen and actually zoom and pan a map. So 1996 was actually when a particular product came out from Esri, which was called ArcObjects IMS, and that was actually what I built. I did a graduate degree, and I actually wrote an application, WebGIS application. So the world of mapping and digital geography, geospatial, digital geospatial, really started out in terms of sort of popular access was in 1996, and I'll be cautious about how I say that, and let me, in a moment, I'll preface that. I'll give you a bit more background on that. 2005 was a very notable time for the web mapping. Google Maps was launched. Google Maps transformed the world of the web and maps. Why? They gave us a lot of access to data, and they gave us an interface, an application which was easy to use. Before 2005, if you actually worked with a map application online, it actually refreshed every time you zoomed or panned the map, which was an incredibly ghastly experience. But it was the only technology then that we had. So imagine it flashing in the map. What Google Maps did was they introduced this notion of slippy maps. So slippy maps, and if you go to Google Maps now, you'll see it, or actually any mapping product that's on the web. If you zoom in, if you pan, you see panels come in seamlessly. So it's a really nice experience. So again, Google Maps introduces to lots of data. So we could see satellite imagery, we could see restaurants on top of that map, and all sorts of other information on top of that map. And it introduced a really great user experience. Some of the other companies that were in the GIS space really sort of watched what Google had done and copied them and introduced the same kind of concept. 2006 was notable as well because we started to get to Amazon Web Services came out then. So we actually got, instead of people hosting what they were doing in their own premises, we could actually do it in the cloud. So cloud computing started to evolve in about 2006. I didn't actually realize until I looked this up it was that early. 2007, someone's chatting to me. Oh, nice to have you on. 2007 and 2010 were very notable because we got the iPhone 1 was in 2007. In 2010 was when we saw the iPad 1 as well. So prior to that, when I finished my graduate degree, I was actually writing web applications for the web, and a lot of it was just really used for mapping, essentially bringing data sets together so you could map that data. 2007, 2010, with the introduction of mobile, really was a huge step forward for the geospatial industry and GIS particularly. It meant that we had devices which were portable computers which had GPS built in. And that meant that as we moved around, we could find out who was around us, what was around us. So it really transformed the geospatial industry, that we could actually see data on our mobile devices, and the interest in geospatial technology and maps became enormous, and we evolved this huge consumer market. 2016 is really relevant to what we'll be talking about here. So 2016 was really when we started to see the maturity of sensors, and I put AI, but really artificial intelligence, I really mean analytics. So we were beginning to collect huge amounts of data from these miniature sensors, and we had the ability to analyze that data. And again, that will be super relevant to what we'll be talking about here. So that's a bit of history. Let me talk about Geospatial 1.0. So Geospatial 1.0 is $8 billion niche. Now, a niche sounds like a little small thing. $8 billion is a lot of money. So we've lived through a period of time where we've seen the evolution of geospatial technology, predominantly in the GIS space. How's that? How would I simply categorize what that looks like? Well, it's largely a public sector customer base. So it's in the US, it's federal customers, state and local customers. Similarly across the world, it's a lot of public sector usage. A lot of it's centered on the GIS and mapping departments, and people have asked me why that is. The reason for that is, back in time when folks like myself were doing GIS and learning it at college, we were learning GIS as geographers. So we were essentially being marketed to by the GIS and geospatial companies. When we left doing our studies, a lot of us moved into the public sector and applied what we knew there. So there's a real base of folks that live in the public sector that know mapping and GIS and apply it. I've put the third point down as it's a really key point to the differentiator between what I see as Geospatial 1.0 and Geospatial 2.0. And I should have added a note before I started this conversation. Some of the elements here are me really trying to connect dots. So there's pieces here that are opinions of mine, that are reflections on the 25 years I've been in the industry, particular things that are happening currently. So this notion of 1.0 is really how I see that universe evolving. But the business models that are part of Geospatial 1.0 are key. And they're the primary reason, I think, or one of the primary reasons why there is differentiation between what is 1.0 and what I'll talk about in a minute, which is 2.0. So we've really come to a world where the 1.0 world is GIS dominated, and it's a one-size-fits-all platform. So I use that example of the Swiss Army knife, which is a single device which has got multiple blades. The Geospatial 1.0 world is really buy or subscribe to what we've got, our platform, and we'll provide everything you need. So it's this self-contained world with very, very specific defined business models. So that's the $8 billion niche. 2.0 is I would say the 4 or 5 points that I think define 2.0 are in this slide. So the key drivers of 2.0 are new automated data collection techniques. And I've mentioned, I'll talk about that a bit more in a moment. We've moved from a world where, in the early days where I was working in the University of Utah and as a developer in the 1.0 world, data was really hard to find. Base map data, overlay data, layers as we call it in the GIS world, were very difficult to find. A lot of that data was actually collected manually. So whether it was digitizing, whether it was going out and manually collecting data, various techniques were done, but a lot of it was done manually. So there are accuracy questions there, variable and the quantity of the data was somewhat limited. So that was number one. The second driver, and I've mentioned already, is now we can analyze these large data sets. So we can automate many things that we couldn't do before. And that's another important point here. I also see Geospatial 2.0 as a loose-knit collection of small, medium companies. So we've got groups of organizations which are in this space who are not necessarily connected at the minute. We've got data collectors, we've got AI companies, we've got geospatial companies. We've got a mixture of companies, all which are in this space and are selling their wares in this space. I think a key point, that third point, is a huge differentiator. The 1.0 world is controlled and dominated by geospatial companies. The 2.0 world is not. The 2.0 world is happening in spite of geospatial. So it's a natural evolution of where we are. And it isn't controlled by the geospatial industry or GIS industry. I also see it as an open, innovation-driven environment. And I'll talk a bit more about that in a moment. The last point is a big one. It's still in its infancy, that whole world. So I need to give a shout out to Josh Gilbert and Gopal. I won't try and pronounce Gopal's last name, but they're from SUST Global. And they are the guys that actually started using this term Geospatial 2.0. I actually believe it was used before these guys were talking about it, but they were the ones that have written some articles recently on Geospatial 2.0. The whole idea of Geospatial 2.0 has sort of been in my head, but they've sort of helped to put it under a label, if you like, and evolve the thinking behind it. Now, it's an evolving thought process, it's an evolving parallel with 1.0 that's still yet to be fully defined. I don't necessarily see exactly eye to eye with Josh and Gopal about what it actually looks like, but we share lots of similarities. So shout out to them for the terminology. And they've written a couple of really interesting articles on it, which it's worth you taking a look at if you have the time. So 1.0 versus 2.0. There was lots of talk about 1.0 migrating into something and evolving wider. I actually believe we're talking about two universes now. So I don't believe that 2.0 is going to replace 1.0. Like I say there, world. I see an overlap between the two, but they're going to live quite separately. I think the 2.0 will be focused in the sectors that 1.0 have never been able to reach. So the 1.0 world, as I've kind of defined it, is very much in the public sector. It's very much GIS people selling to GIS people. And one of the challenges of the 1.0 world that some of you that are in it have read and faced yourselves is, how do you take the 1.0 world and move it into the wider organization? So how do you move 1.0 technology, mapping primarily, it was focused on mapping technology into the wider audience. So how do you bring it to C-level executives in a city or a state? It's a big challenge for 1.0. And some of that has been to do with the fact it's been, well, the 1.0 world has marketed itself as mapping software instead of business intelligence software. So there's some legacy things that have created that. But I see the 2.0 world as being, if the 1.0 world is $8 billion, the 2.0 world is going to be considerably bigger. It's going to serve the rest of particularly the business world. And I've made that point at the end. It'll bring geospatial data to a wide commercial user base. So it'll actually bridge that gap between the groups that are doing the 1.0 work to a much wider audience. So we'll start to bring in the rest of the commercial sector. So you're talking insurance, finance sectors. We're seeing healthcare now with the COVID pandemic, really looking at how geospatial can help them on this big challenge we've got. So parallel universes. Now I've put a long quote here, which you'll all start reading, but I probably should read it back to you. The underlying words in this quote are most important. So the real value of Geospatial 2.0 lies in the data and the insights derived from that data. There's no shortage of tech to build products or solutions, but those that endure will be those that are built in close collaboration with customers they set out to serve. Now, I didn't ask the person who gave me that quote to allow me to quote him, so he came from a geospatial organization, but I thought that quote needed to be included here because the three words I use there are absolutely critical in the 2.0 conversation. It's data-driven, it provides insight, and everything starts with a customer. And I'll talk a little bit more about that in a minute, and I'll tell a story, which I hope helps paint that picture. Another long quote, but one I wanted to include. This is from a merger and acquisitions firm. Toward the end of FY 2019 and beginning of 2020, we've noticed a significant increase in deal size for geospatial acquisition candidates. Private equity firms and strategic acquirers are both writing large checks for aerial imagery and location intelligence. So why would I include that? There's a much wider interest in what's going on in the 2.0 world. In this particular case, aerial imagery is clearly a data collection source. Location intelligence brings the geospatial, the AI piece, the analytic piece together. So there's there's an increasing amount of activity in the banking world, investment banking world around this, and lots of these companies that are appearing that's getting a lot of interest from the investment world. That's certainly not the case so much in the 1.0 world. So again, I talk about this world that's emerging, and there's a lot of interest from organizations that didn't necessarily historically look at the geospatial sector now in these emerging areas within, again, what is called the 2.0 world. So three reports I wanted to point you at. If you haven't read them, I really thoroughly recommend that you go and look at them. And these have just recently come out. So the UN GGIM Future Trends Report, there was a conference about a month or so ago, 3 Tuesdays, where an international group got together and discussed the future. Well, they discussed the geospatial industry overall, but the Ordnance Survey, who were working with the United Nations here, they wrote a Future Trends Report, which you should read. It really is a report which looks 5 to 10 years ahead and tries to look at where we are today, some of the challenges we've got, and some of the opportunities. My particular focus and what really caught my attention in that report is the innovations piece of that. And again, I'll touch on that again as we move through. So that's an important report. The Geospatial Commission Strategy Report is another one. So this is a UK-based organisation, and they've just written quite a long report, and it has similarities to the UN GGIM report. But again, it highlights the big opportunities that are now presented by geospatial data and the analysis of that data, and how that path forward might look. So lots of questions are being asked in those papers, those 2 reports, and I think it behooves us within the geospatial community to start thinking about what's in those reports and how we might move things forward. And again, I would suggest that the 2.0 evolution will happen in spite of the geospatial. So it's happening anyway, with us folks who are from the geospatial world involved or not involved. The last one is the Knowledge Transfer Network and Ordnance Survey Power of Place publication. That's only just come out. And again, that's a little bit more focused, and they actually use the 2.0 terminology within that publication. But it covers similar ground to the other ones. And again, mapping that path forward, pun intended, on where this industry is going. So some important reports, and if you haven't had a chance to read them, I would suggest strongly that you take a look at them. There's some really important information in them. And in fact, some of the thinking that I've got behind this paper that I wrote, the article that I wrote, and this webinar were driven by some of the things in those reports. So let's dive in deep a little bit deeper, and look at the three elements which really make up the 2.0 world. So it's location data, it's analytics, and it's a geospatial framework and visualization. So let's just look at each of those 3 areas individually. Start with location data. Now, I've mentioned the fact that we've seen big advances in sensor technology. So we're now able to collect vast amounts of data very quickly that's highly accurate. Big change. So if one looks at those, where that data is being collected, you'll read a lot about satellite imagery. And in that second quote from the M&A company, they mention interest in satellite companies. Planet is a big one. There's a lot of other ones that are pushing new satellites up into space. They're using the newest sensors that can collect highly accurate data of different types, and they're collecting it very, very regularly now. Aerial imagery, that's another one, or sorry, I should say aerial data collection. So that's from aeroplanes, so that's the next level down. So we can put in sensors in aeroplanes and fly those at a fixed height. Moving lower are drones, and that's an emerging market now. There's a lot of action in the drone market. Now, the sensors have got smaller and smaller. So, for example, LiDAR, which I'll talk about in a second, we've now miniaturized LiDAR sensors down to a point where we can actually put them on drones. Now, they're still quite expensive, and drones have a tendency to crash. So there's a bit of a challenge there in terms of the price. But the point is, at that next level, much closer to the Earth, drones are now collecting ever more amounts of data. And those drones can collect localized data as well. So if we wanted to fly a building or a field, drones are able to do that. Terrestrial is land-based data collection. So we can put tripods up and we can collect LiDAR, for example, and you'll see guys on the road doing that kind of thing. Cat's just got. And then the last one is indoor. We can actually move inside of a building, and we can collect data with handheld devices. And I worked for Hexagon for a couple of years, and they've got some amazing technology within their Leica group. And they just released an amazing, quite an interesting device. They use the word amazing. It is an amazing indoor handheld device, which is tiny. It's a LiDAR, a sensor, actually collect data on the inside of a building. So the types of data we're collecting, imagery is something we've collected for a long time. We're collecting a lot more imagery now of much higher resolution in each of those levels, you know, from the satellite all the way down. LiDAR, if you don't know what LiDAR is, worth looking up. It's basically laser-driven data collection. So you're literally sending a laser beam out from a device, and it bounces back, and you're collecting not only the XY position of that bounce back, but also the Z or the Z element of that. So we can build a 3D world using LiDAR now. And I chucked some books to the side of me. If you're interested in LiDAR, there's a really great book called The Laser That's Changing the World by Todd Neff. That book there is really a great book on the world of LiDAR and what's happening in that world. And you'll hear a lot about LiDAR with autonomous cars as well. But LiDAR is now being used to actually build a lot of things and build these 3D worlds, digital reality, digital twins. Radar's very interesting. I've only just been introduced to radar. So radar is now being used to detect underground assets. So you could drive along a road and you can actually see beneath the ground and see the pipes that are underneath that particular road. So a lot of applications of radar. Radar is really good at detecting slight movements in slopes as well. So slope failure, for example, is another application of that. And then the other piece is IoT devices. So we've now created this world where we can actually put a sensor on a stationary device. So think of I always use the example of a piece of equipment that gives out heat, power unit, for example. It's stationary, but you're wondering about the heat that's given out by that device. If it raises above a threshold, you've got a problem. We can now stream that data back and monitor devices automatically. If the device goes above a certain threshold temperature, for example, we can do something. Another IoT phenomena is obviously movement. So we can track vehicles, we can track people. And again, I mentioned COVID before. We can now track the movement of people. People may have COVID, where they've been, etc. Now there's a lot of privacy issues there, but we've now created a world where we can track movement of things and people, and we can monitor things that are stationary, and we can get alerts if there's a challenge that goes over a threat. So we're collecting data at multiple levels of multiple different types. Now 80% plus of data has location built into it. Is that data being used effectively, that locational aspect of that data? That's really where the 2.0 world comes in. Lots of people have got lots of data, they don't know what to do with it. And location is an absolute core piece of the data they're collecting. So I leave that last point. You often hear that, but the importance of geospatial data and the geospatial industry is, well, everything happens somewhere. And what we're essentially doing with this data ultimately is collecting information about, or data about our real world, fusing it together so we can actually come to decisions about things that affect our world. So it means that that data is ever more important, ever more useful. Analytics. There's been a lot of interest in AI, and frankly, AI is a little bit, there's maybe too much talk. we're really talking about analytics here. And I wrote a blog post. I write blog posts like I do these type of webinars to really connect dots. I like to sort of think big picture things and think, let's connect some dots together and think about this stuff. And I wrote a blog post about analytics, and I realized I retitled it after I'd written it. I put it Finding a Needle in a Haystack. And essentially, much of analytics is doing that. It's finding a needle in a haystack. So when you've got huge data sets, your brain can't process all of that data that's there, but AI can, and analytics. So we can actually isolate and find very specific answers to questions by using analytics. And there's lots of types of analytics. There's AI, there's spatial statistics, there's modeling. Within the GIS world, there's a lot of algorithms and services that provide a deeper level, a deeper insight into the data that you're using. So analytics is absolutely key. So I've mentioned there, analytics really provides answers to very specific questions. 3 examples I've given there, and there are many. Change detection. So we spoke earlier about the importance of satellite imagery and a lot of interest from the investment community there. There's a lot of companies that are launching new satellites. Well, they're collecting masses of data and they're making that data available to folks. So you can actually fly areas daily and see, you can detect areas. So imagine we're talking imagery here and we're taking images of the ground. Well, AI can actually detect the subtlest of changes in that ground. Now, think about where you could apply that. Agriculture is an obvious one. Smart cities is an obvious one. If you want to see the changes in a city over time, you can see that. So over a short period of time, over a long period of time. Where change detection maybe become relevant is, think about insurance companies or insuring crops. Think about the finance industry. You can actually make predictions about the success of a crop by looking at the ground and seeing changes in the ground over time. Are we going to get a successful corn crop this year? So a lot of things can be done using change detection. And that's one example of how AI can look at pictures and process that information and give you information back, give you insight back, essentially. Steve Nouri, N-O-U-R-I, is a really interesting guy who works in AI in Australia. And he writes on LinkedIn, I would look him up in LinkedIn if you're interested in AI. He provides 2 or 3 examples of the application of AI daily. I'm amazed where he gets the information from. But he came up with, he showed one the other day, which was using AI to analyze shopper behavior. So where are folks going? So this is indoor geospatial. Where are folks moving around to? Where are they hovering? Which shelf are they looking at? So you can actually do you can actually understand shopper behavior in a much greater way by collecting data on their behavior inside a building, inside a shop, and then analyzing it using AI. So shopper behavior was an interesting one I'd never thought about before, and then Steve showed a sort of a video of how it can be applied, and I thought, that's very cool. So Steve Nouri is well worth following if you're interested in some of the applications of AI. Predictive analysis is something that gets a lot of attention. Predictive analysis, and I'll talk about predictive analysis in a moment, but predictive analysis is where one can take that data, look historically on what's happened, and make predictions about the future. I'm really simplifying predictive analysis there. An example of work that my group have been doing is around mining. So in mines, I'm in Salt Lake City, and Rio Tinto, or very big copper mine. I think it's one of the biggest in the world, just across the valley on the west side of Salt Lake. They have slides in that mine all the time, big ones and small ones. And they use radar to actually look at slope movements, and millimeter movements can be detected using radar. But one of the areas that is challenging for them is actually to predict slides. And it's not the big slides that are challenging, it's small slides. So we're working with a group to actually use AI to predict what are problematic slopes potentially based on historical data. We know this happened here. Based on that evidence and information we've got historically, we're looking at the slope, and based on what the movements we're seeing, some other factors It gives them a chance to actually predict what slides, the most problematic areas that could slide. Which, I mean, that's a huge issue. It saves, if there is a slide, it shuts the mine down, potentially damages equipment, and so some big issues can be solved using predictive analysis. And there are a million of examples of like this out there. So frameworks and visualization, I sort of see that as a third leg of this sort of 2.0 conversation. And it's kind of where, I mean, part where our technology sort of comes in and brings it all together. We've spoken about the data, which is really the fuel to answer questions, and that we've got lots more data we're now collecting. We've spoken about the analytics that can process that data and help us get insight and find that needle in a haystack. But really the frameworks are how we pull that stuff together. And within the framework is the ability to visualize that data. So at the top there, I've put that word glue. Some people, I always like people who comment on the blog posts that I write. And glue is something that somebody protested about. They didn't really like the idea of glue, but in my mind, visually, I can kind of picture it. It glues it all together. Let me just take a quick sip of coffee, sorry. And really, you'll see that word data fusion used a lot. How do we pull all this data together in one place and visualize it so we can understand it? That's not just the raw data, that could also be processed data from analytics. I've included the word web there. To me, and I told the story of in 1996 when I started working with WebGIS, I always saw the web as this democratizing technology. So instead of people working on desktop computing, which is very important still in the 1.0 world, desktop GIS is hugely important and hugely valuable. We've now started to use web technology, and web technology has moved to a point now where we can actually bring huge amounts of data together and visualize it. I remember I mentioned back in the day when with ArcIMS and with some of the early technology, open source technologies I was working with, the map flashed. That was actually because you were making a request to a server, it generated a new image, and you got the single image back. Now the web has got to a point where we can actually visualize huge amounts of data very quickly. So I mentioned LiDAR and point clouds. We can view these massive data sets really easily over the web. So 3D GIS or 3D Geospatial has become a much bigger deal. And you're beginning to see this notion of digital twins and digital reality where I can actually drill down and see things in 3D. So I get a 3D representation of the world. I also mentioned multidimensional data there in that third point. Multidimensional means 2 dimensions, 3 dimensions, and dynamic data. That means 4 dimensions, movement, and so monitoring in real time and tracking movement. I'm going to paint that picture in a minute with an example. So we're providing data-driven insights for decision making. I think ultimately that's our goal. And both the 1.0 world and the 2.0 world is primarily, that's our focus really, is to get to be data-driven and provide insight ultimately for decision making. So let's tell a story. I've bobbed on about, or gone on about the background to this stuff, but let me tell you a data story. I mentioned that in that first quote, I mentioned how important the customer is, how important data is. Everything starts there. So last year, someone mentioned to me Vision Zero. And I wondered what this Vision Zero thing was, and I realized it's all surrounding this notion of road safety. Vision Zero started, as I understand, in Sweden. The Swedes decided they needed to cut down on the fatal and big injury accidents that happen in Sweden. So they focused their energies on how do they do that. And there were really 2 aspects to what they were trying to do. They were trying to understand, they were trying to re-engineer roads to make them safer. They were also trying to change the behavior of drivers. And now engineering was a very important part of both these aspects, changing behavior and making sure that they guided people and slowed people down, for example. Speed kills, obviously. Now that notion of Vision Zero is spread throughout the world, and the US was a little slow in moving forward on that one, but now it's a very big focus over here. How do we cut down on fatalities on the road and serious injuries? So I was really interested in that because fundamentally that struck me as a geospatial question. You know, when we go back to that notion of something which happens somewhere, or the geospatial notion, a place on Earth, well, accidents happen in particular places. So I decided it was probably a good idea to explore this a bit more. Is there what is the problem, and what's the path that people currently do to try and get to a solution? So I sat down with some engineers, some traffic engineers, and asked them their workflow. And they told me where everything starts with the police. The police go out and they collect data on an accident. So they'll collect where it was, they'll collect what happens, whether there are injuries, etc. So police reports are collated, and that's the basic data set that these traffic engineers use. So they wanted to, so there are lots of technologies out that allow them now. GIS is one, and various geospatial platforms. You know, we can visualize that data easily. And here's one example, and I'm not going to talk technology apart from the last slide in this. This isn't a technology conversation. This is more a conversation about where the geospatial world moves. So I'm not really going to talk anything about technology, but this is a way to visualize data. And I really wanted to underline the fact that historically, we've really lived in a two-dimensional world. Why? Because most data that's been collected historically has been two-dimensional, i.e. an X and a Y. It happened at this particular location. And for traffic engineers, the first question they ask is, where are the most problematic intersections, in this case, in any particular place? And this is in Chattanooga in the US. And what we've got here is essentially a visual representation of where all that, where the most problematic places are for collision. So you'll see here we've got a combination of things. We've got heat maps, which is the coloring obviously there. The red obviously indicates higher collision rates, and the green area is less. And then we've also got clustering. So we've got the actual number of collisions that happen at each place. So that's a really important first step for the traffic engineers, to actually have a visual representation of where the problem places are in that city. We've also broken some of this down in this dashboard, some of the other data down. So I want to filter the data. So it's not for the traffic engineers about where the absolute collisions have occurred, the absolute numbers I should say. They're really more interested in fatalities and serious injuries. So we may have an intersection where there are only 20 crashes versus 200 somewhere else, but 50% of those were fatalities. That's a very important thing for traffic engineers, because they want to obviously focus on this notion of vision zero and cutting down on the number of injuries and deaths. So this information that's presented here is a filtering of what really the police have collected. So you've got the type of collision, whether there was a fatalities or not, what date it happened, etc. So as you're trying to sort of use data to tell that story, two-dimensional data is really valuable. It starts a process of isolating those areas. But the key question I asked those traffic engineers was, once you've found this information out, you've taken the police data that's been collected, you've mapped it, what do you do next? And they looked at me and scratched their noses like I'm doing here and said, well, we drive out to those most problematic intersections. We'll actually stand on the corner and we'll look around. We'll see, is it overhanging vegetation that's causing the problem? Is it a broken guardrail? They'll assess that particular location. They'll take measurements and do various things on site. So they go into a diagnostics phase. And the diagnostics phase involves, again, the first place is, let's go look at that intersection. My question to them was, suppose you could see that intersection on your computer. And they'd really not had that conversation before, at least the guys I spoke to. And they said, well, that would be wonderful. We wouldn't then have to drive out to these various places and save us a lot of time. This isn't the greatest of screenshots, I apologize, actually taken from a video, but this is actually LiDAR data of one of the intersections on that previous map. So this is actually in Chattanooga, and this is a three-dimensional view of that intersection. So we can explore in a web browser this view. We can actually see if there is an overhanging vegetation issue by actually zooming in to the tree there and looking around, assessing it. So we can actually assess it in 3 dimensions. The data here was collected with a combination of drone and terrestrial LiDAR. Somebody drove down that road and collected LiDAR and imagery as they drove down that road. So I mentioned that the speed that we can collect this 3-dimensional data. So we've really recreated that intersection digitally. And that's the power of 3D. And when you hear about this notion, and I don't really like the term digital twin, I like the term digital reality, because digital reality gives us a sense of place. It gives us a sense of what does that intersection look like. The other thing that you can't actually see here is we've included GIS data. So there's an actual green point in the middle here, which was actually where collisions have happened. And there are a whole load of points here. So we can actually include additional information that's not available to those guys if they were standing in the field. They can see in this interface where all those collisions happened, what type of collisions they were. So it gives them ever more diagnostic information. Another component to this, which is only recently available, is we can now vehicles have got sensors in them. So we can actually collect information from the vehicles that are driving through that intersection. And I was interested, I was actually chatting with a company based in England that are doing this work, and actually most of the work's actually done in the US here. And they collect data from the sensors on these vehicles. And ever more vehicles we know have got sensors on them. But they weren't just collecting the location of those vehicles as they moved through the intersection. They were collecting information like harsh braking, harsh acceleration, whether seatbelts were worn, etc., etc. So again, we can overlay that data in this interface to show those particular locations in that intersections where people were harsh braking. So this is all evidence that these guys can use to understand better why these intersections or these particular intersections are so problematic. So again, the power of data. We've spoken about 2D patterns. We've spoken about 3D giving a sense of place and these additional data sets that we can use to help diagnose the problem. A third element to this, again, in conversation, was, but again, now we're collecting real-time data, or at least time-based data. So that's the 4th dimension of this location data. So I've called that the real-time pulse. So yeah, we can actually show traffic moving through those intersections over time. And again, all evidence for these guys to understand better the whys of these particular locations. So we're using 2D, 3D, and 4D to help them diagnose problems. One other thing I'll add to that, and this, I use this image, even though this image is suggests movement of vehicles. What this image actually shows is actual collisions in that intersection. So traffic engineers were less bothered about this because insurance companies, the police, other groups are really interested in, well, let me see examples of collisions that happen there. We've actually got LiDAR, handheld LiDAR data here, which shows those vehicles actually in collision. So one of those has actually got a motorbike that's smacked against the side of it. So again, this is more information we're collecting, which is location-based around the whole world of collisions. One other thing, predictive analysis. Since we're now collecting all this data, we can push this data into AI algorithms, and we can actually use that to make predictions. So we can use data, for example, to predict collisions in a particular day based on weather, etc., etc. So we can predict ahead of time what's actually happening on the road. But we can also predict from going back to the traffic engineers example. Suppose I put a roundabout at that intersection. What predictively would that result in? What do we know would happen if we did that? You know, we can put all these variables in. It would cut the speed down, etc., etc. But if we're going to try and make predictions around fatalities, etc., there's ways we can use these combination of data sets, focus on that place to actually understand the effects of a treatment, as the traffic engineers say. So that's kind of a customer-centric, data-driven story, and it's what I would say is it's a kind of a 2.0 story, that one, because we're really focused on A, the customer, and B, telling stories, or at least building stories around that's powered by data to solve particular problems. Some of you will say that's also a 1.0 story, and I would say you can do that in a 1.0 world, but given the background I've just provided, this is now stuff that we can do in this 2.0 world, which is gluing all this stuff together in an open framework. So this is the only architecture diagram I really wanted to do, and I didn't want to point at any technologies here because I don't think that we're at that point where it makes sense to talk that, and it isn't my place to do that either. So I've actually included a couple of, well, this framework is how I see where the 2.0 world is moving to. It's including everybody. So I don't see 2.0 as excluding the 1.0 world. I believe that 1.0 and 2.0 come together, essentially. But I believe that the 2.0 is powered by the new data that we've now got available to us, new location-based data. It's powered by analytics. It's in an open framework. And I've given a couple of examples of open frameworks that are out there. These are actually folks that are in Australia. They're called Data 61. I'm not sure if they're part of the Australian government or one of the provinces on the states there. It might be New South Wales. But anyway, they pulled together a couple of frameworks which are open frameworks which allow us to sort of glue this stuff together. And they don't exclude anything. I mean, I've put GIS platforms in that bottom left corner. It's an open framework that actually allows access to and can access data that's in a GIS, can use services that are within a GIS. So it isn't a 1.0 versus 2.0 conversation. This is really much an inclusive, and I've used that word in the title there, an inclusive framework, because everyone can access these types of frameworks. I'm not saying that Magna and Terrier are what's going to happen, but I know that a lot of the big agencies that are writing the reports that I mentioned, you know, UNGGIM and the Geospatial Commission in the UK, they're beginning to talk about these type of open frameworks. And it may be that we build these frameworks out within sort of the public sector, and that gives us that framework to build off of. But that's the kind of world that I'm seeing that 2.0 is. It's an inclusive world. Organizations can use these open frameworks. They can build in analytics, bring in their own data. They can make them private. You can build companies out of that. You can leave it open. You can include the GIS world in that. So, or the 1.0 world in that. So it's very much an inclusive world that I believe that we're kind of going towards. Geospatial 2.0 and you. And I'm looking at the time, we're 5 minutes off of an hour, so I'm hoping I'm not going to go long here. This isn't a very good diagram, it's got too many words on it. But it's, I'm suggesting here that geospatial is becoming ubiquitous. I mean, we organize our world geographically. Geospatial is a core piece of what we do. We can now start to solve problems once unimaginable. I think that we're now entering a phase of accelerated innovation within the geospatial world. And I think the 2.0 framework is going to drive innovation. I think we've now moved into a place where we're beginning to bring these pieces together, and it's going to drive innovation. So I think those disconnected elements that make up the 2.0 world by the sort of definition I've provided here are now beginning to come together. So we've got groups that are now, who are data providers, you know, the satellite imagery guys, the guys that are collecting drone data. We've got the analytics community who are building out algorithms that do very particular things. I've given some examples of that. We've got the geospatial commercial organizations that are now building out some of these frameworks, thinking things through. And we've also got the geospatial public organizations. And again, I point back to those reports that have come out. There's a lot of interest in where this is going to go. There's people thinking about the path forward. And I think that we're really talking about this innovative world, which is data-driven. And I think that we're now beginning to see the come together of these different groups. Now, there's a lot of people in those groups that don't know what they don't know. They don't know that these, you know, data providers are wondering how they best sell their services. Analytics engines, who can we sell these algorithms to solve a problem? I think, and the bottom point for those of you that are the geospatial folks on this call, Geospatial 2.0 still lacks geospatial experts. A lot of us, I should say you, because I'm now I sort of sit in two camps, one and two, are still focused in the sort of the geospatial world, in the geospatial 1.0 world. A lot of you are sort of technologists, a lot of you are sort of looking at it from sort of a technology perspective, beginning to think about how you spread the word across your organizations. And a lot of public sector organizations. How do we bring this great technology to the wider group? But I think the 2.0 isn't going to happen in spite of geospatial people. This happening anyway. I think what's missing in Geospatial 2.0 are us, actually. In some cases, I had some conversation with folks who are sort of sitting in the Geospatial 2.0 world, and they said to me, we're kind of reinventing the wheel in some ways because we're doing it on our own. And to me, it was really bringing in some of our expertise in there. The OGC I was talking to the other day, and they're bringing data scientists in to understand the world of location data, how to do with it. So there's training on the technical side for those that don't get geospatial, but I would argue strongly that we need geospatial translators in 2.0. And it's those guys that can tell the story that I just told for traffic engineers, getting in front of customers, understanding their problems and painting those pictures for them as to how they can leverage data they've already got to actually solve problems they didn't even realize they could solve. So the power of geospatial is enormous. And again, in my mind, we're digitizing our world outside, and we can then include other data in that world that we couldn't if we were standing on that street corner trying to understand why there are so many crashes on this corner. We can fuse data together in a digital way to understand so many problems that the world's facing today. And we've got many problems that geospatial can and should be tackling. So for those of you that are geospatial thinkers, we need more of you in the Geospatial 2.0 world. I'll briefly mention my group. So I took it off our website. Our purpose and mission is to help spawn new services, solutions, and businesses leveraging the new Geospatial 2.0 paradigm. We kind of come from it from really the customer data, as you can tell. We come from it from the customer data side of things. I think that for 2.0 to really emerge and for geospatial folks to help in this world, we have to understand the customers. We have to be building solutions based on customer needs and problems, and we have to paint that picture for them. I mean, it's about holding their hands, taking them down the path to a solution, leveraging location data, leveraging analytics as needs be, and bring it together so they can visualize it easily. And that doesn't necessarily mean a map-centric interface. That can be dashboards. Dashboards have become incredibly popular. It could be other forms of asking those questions and getting information back. So again, it's all geospatial because it's powered by this location-based data. But it behooves us now to really get into insurance companies, banks, the healthcare sectors, the financial sectors, and really start to understand their problems and show them, help guide them down the path to solutions. And just one last point before I finish, 1 minute over. I believe that it's really important that we start to build out prototypes. And one of the things that my group are kind of focused on is teasing out some of these problems, working with customers, maybe in some of these non-traditional sectors, helping them understand that journey to a solution, and then prototyping it to proof out what could be done to solve these particular problems. So I see that as an important journey, and in our world, we're less technology focused, even though we understand the technology. We're much more on the front end, providing advice, guidance, hand-holding, etc. So that's our world. That's my. I'll actually post this this on the web. This video, this webinar. I'm really interested in you guys' feedback. I mean, this has been kind of I wrote down Malcolm Gladwell. He writes lots of books and stuff, and thinks about things and asks people questions. Somewhat that's what I've done here, but I do believe there is a 2.0 world emerging, and it's been sort of validated by many people and many things I've read. So I think we're entering this really nice parallel world, which is powered by geospatial. So any thoughts you've got, any feedback, tell me I'm wrong, tell me I'm right. Love to hear it. And we've got people asking questions. I think if you guys want to maybe, since we're over time, email me. I'm really happy to answer any questions you've got. You can ping me as well. Actually, my contact information is here. So there's my email address. There's my phone number. I'll continue to write blog posts I know many of you comment on them. I always love comments on blog posts. Let me know your thoughts. And we'll leave it there. And then I'll actually pick up on the comments, and then anyone's comments, I'll come back to. We'll quit there. Thanks for your time. Look forward to continuing the conversation. Thanks a lot.